In the previous video, we learned about zombies and how they're created so we know the risks of manual memory management. In this video, we're going to look at 8 things you can do to improve memory performance. We'll look at what we should avoid and what we should know before making programming decisions. 1. Use lazy loading when appropriate. You may feel the impulse to load all of your resources into memory when your application loads, so that your data is always available when your user needs it. Preloading data in this way may come with the side effect of a sluggish initial user experience. Keep in mind that most people only use their mobile devices in short bursts, often less than 30 seconds. That said, you may be loading data into memory that's not crucial to the user's session. Rather than loading your data on application startup, you should be using lazy stored properties whenever possible. A lazy stored property, as you know, is a property whose initial value is not calculated until the first time it's accessed. So, if you need to create objects, retrieve data from a cache, or import data by some other means, you should consider using a lazy property. 2. Reduce reference counts with optionals. Optionals allow you to set your object's value to nil, which lowers the reference count of classes. Setting your objects to nil when you no longer need them is the easiest way to clean up memory. This works hand in hand with Arc. As you set your unused objects to nil, your instance's reference count decrements. When your counts reach 0, of course, Arc will deinitialize and free up memory. 3. Break strong reference cycles by using weak or unowned. We've covered this topic at length earlier in this section, but we'll briefly recap. When creating recursive references between classes, or when using self inside of a closure, make sure that you either use the weak or unowned keyword to break the strong reference, allowing Arc to deinitialize your instance. 4. Proper casting reduces instance counts. While some operations don't have an impact on memory usage, others do. For example, we can change a value's type from its original type into another type by passing it into the new type's initializer. When we change types this way, we're creating a new instance of the object, which has memory implications. Instead, make sure to utilize Swift's as keyword to cast your values to a new type whenever possible. Casting does not create a new instance, nor does it have the same memory implications. 5. Understand the difference between reference types and value types. We discussed this somewhat in Section 1, but it's an important facet to programming in any language we encounter, so we'll reiterate here. Both reference types and value types have their own advantages and their own dangers. Structs and enums are value types, which means they are copied rather than referenced, which can be more memory intensive since they are copying their values each time they are assigned to another instance, effectively doubling memory usage. Now the trade-off is that copying them allows them to be accessed directly, which of course is optimal for thread-safe performance. Classes, as we've already discussed, don't behave this way because they are reference types. This means they don't copy when they are assigned. Instead, they create another reference for Arc to track. 6. To avoid creating copies, utilize inout. Functions capture the values passed into them by creating new copies. However, Swift offers an inout keyword. Inout allows us to pass an object into a function and modify the original rather than creating a new copy. This has the ability to improve memory performance depending on what you pass in and what type of operation you're performing inside your function. 7. Avoid unnecessary caching. Caching frequently accessed items is an excellent way to provide immediate data to your user, which can enrich the user experience. Caching is often the right choice, but keep in mind that NSCache and other caching libraries will usually discard parts of the cache when you're running low on memory, causing potential issues down the road. 8. Know the benefits of object-oriented programming over functional programming. Remember that functional programming uses immutable states, meaning that certain operations can be devastating on your memory. In some cases, it's best to utilize OOP's mutable states to reference one instance rather than creating new ones. In this video, we looked at 8 approaches to improving your memory performance. One could easily spend hours investigating each one of these techniques, and one absolutely should. If you take the time now to make sure you fully understand how memory works, you'll save yourself countless hours in troubleshooting and debugging over the course of your career. In this section, we've learned about the allocation and deallocation of memory. We learned about Swift's ARC memory management system. We also introduced Xcode's Instruments tool and isolated both memory leaks and zombies. In the next section, we'll learn how to include frameworks into our application and how to make Swift play nice with both C and Objective-C for interoperability.